I'm going to discuss how to remove radicals from denominators in expressions. Sometimes it is desirable or even necessary to remove radicals from denominators. All right, so I'll do a couple of examples. Suppose we had 1 over the square root of 3. Is there an equivalent form we can find that does not have a radical in the denominator? All right. Look what happens if we multiply the top and bottom by the square root of 3 and simplify. If we do that, we will get the square root of 3 on top. On bottom, root 3 times root 3, that's just 3. So there I've derived an equivalent form that does not have a radical in the denominator. Okay? Now, if we have 7 over 2 root 7, so now we have a radical in the denominator and we have something multiplying it. Okay? We're still going to use the same procedure. Multiply the top and bottom by the radical. And so in this example, I will have 7 root 7 on top, and I will have 2 times 7 on bottom, because the square root of 7 times the square root of 7 is 7. All right, and lo and behold, we can reduce our answer. I can eliminate the factor of 7 from the top and bottom. So the answer is the square root of 7 over 2. All right. Now, the procedure does not change if we have variables. Okay? See if you can solve the following example, which has a variable. 3 over the square root of h. Pause the video and use the same procedure I've just shown you to give me an equivalent form that does not have a radical in the denominator. Okay, I'll go ahead and work out this example. I'm going to multiply the top and bottom by the square root of h. So that's going to give me 3 root h over h. I hope that's what you got. Okay, now let's move on to slightly more complicated exercises. Suppose we had the square root of 2 over 3 minus the square root of 6. You can try multiplying the numerator and denominator by the square root of 6, and you will see that that will not achieve our goal of removing radicals from removing the radical or any radical from the denominator. Okay? What you need to do in this situation is you need to multiply the top and bottom by 3 plus the square root of 6. Okay? Now, in general, when you have a binomial, you want to multiply it by a corresponding binomial that has a different sign. So, for example, if your original numerator was a difference, you're going to multiply it by a sum. If you start with a sum, you're going to multiply by a corresponding difference. All right. When you have two binomials and they differ only by the sign, okay, they are referred to as conjugates of each other. So you could say that I'm multiplying the top and bottom by the conjugate of the denominator. Okay? Now, so let's go ahead and simplify, and you will see that conjugates are the way to go. So on top, I'm going to get 3 root 2 plus the square root of 12, because root 2 times root 6 is root 12. On bottom, I'm going to get, well, I have a difference of squares situation. You can FOIL it out. You will see that you will get 3 squared minus the square root of 6 squared. If you don't remember that pattern, go ahead and FOIL it out the long way and you'll see that it's equivalent. All right, so now let's try to simplify. So 3 root 2 and root 12, I can replace that. Let's see, 12 is 4 times 3, so 2 root 3 is equivalent. And on bottom I have 9 minus 6. So the best I can do is the following. 3 root 2 plus 2 root 3 over 3. Okay? Now, I would like you to do an example that involves what I called conjugates. Okay? So try this one. 6 over 3 plus the square root of 3. Pause the video and try to remove the radical from the denominator for that example, please. Okay, so I will go ahead and work it out myself. So I'm going to multiply the top and bottom by the conjugate of the denominator. And I'm going to get 18 minus 6 root 3 on top, and 3 squared minus the square root of 3 squared on bottom. And that's going to be equivalent to 18 minus 6 root 3 all over 9 minus 3, which is a 6. So I can divide both terms on top by 6 to get 3 minus the square root of 3. All right. Now, let's close this video by having you do one more example involving conjugates and variables. If you can do this one, then you're good to go for this topic. The square root of 5x, the product 5x, all over the square root of the product 5x minus 2. Give me an equivalent form that does not have a radical in the denominator. Okay, so again, pause the video and try to do this one now. Okay, so I will go ahead and work it out. The conjugate of the denominator for this example is the square root of the product 5x plus 2. Now, doing the multiplication, I'm going to get 5x plus 2 times the square root of the product 5x on top. On bottom, I'm going to get 5x minus 4. I simply squared the pieces on the bottom two on a binomial from the bottom, from the denominator. So I don't think, let's see, I don't think we can simplify that anymore. So that is the final answer, and I hope that that is what you got.